All right, today we're going to crack open the Economist Toolkit. Ever wonder how they take all the messy, chaotic information from the real world and somehow turn it into these clear, powerful insights? How do they actually separate fact from fiction? Well, let's dive in and find out. So let's kick things off with a big one, a question that probably affects a lot of us. Does a college degree actually cause you to earn more money? I mean, on the surface, it seems obvious, right? But what if it's something else? What if the people who go to college are just, more ambitious to begin with? Or maybe they have better family connections? How in the world do you untangle a real cause from what's just a coincidence? This, right here, is the central mystery economists are trying to solve every single day. You see, to solve puzzles like this one, economists can't just go with a gut feeling. Nope. They need one crucial thing: evidence. We're talking cold, hard facts. And in their world, that evidence has a name: data. Just think of data as the raw material, the bricks and mortar they use to build every single argument and conclusion. Okay, so where does all this crucial evidence, this data, even come from? Well, that brings us to the first part of our investigation. Turns out economists basically have two very different ways they go about gathering it. So on one hand, you've got what's called experimental data. This is really the gold standard. It's where researchers set up a controlled trial, kind of like a medical study for a new drug. But let's be real, you can't exactly put half the country in a control group, right? It's usually impossible or way too expensive or just plain unethical. And that's exactly why economists almost always rely on the other type: observational data. This is where they just observe the world as it is, using information that's already out there, like government surveys or tax records. But here's the catch, and it's a big one. Observational data is absolutely filled with hidden traps. There are two major ones you gotta watch out for. The first is something called confounding variables. We're gonna dive deep into that in a second. The other one is reverse causality. This is where you might get the cause and effect completely backward. For example, think about this. Does putting more police on the street cause more crime? Or does a high crime rate cause a city to hire more police? See? These are the kinds of tricky problems that can totally mislead you if you're not super careful. Now, this data usually comes in three main flavors. First up, we've got cross-sectional data. The easiest way to think about this is like a snapshot. Imagine surveying the wages of 1,000 different workers, but all in the exact same year. So lots of different subjects, but at just one single point in time. Then you have time series data. If cross-sectional data is a snapshot, this is more like a movie, but of just one subject. Think about tracking, say, the US inflation rate every single year for the last 20 years. One subject, but over many moments in time. And finally, we get to the real powerhouse: panel data. This is literally the best of both worlds. Here, you're tracking many different subjects over a long period of time. A great example would be tracking the salary of every single NBA player for the last decade. And this is so powerful because it lets you see individual changes and the bigger trends all at the same time. Okay, so now we know the different types of data. Let's get back to that central problem we talked about. Because when you're just looking at the messy real world, the simple patterns you think you see, well, they can be really deceiving. There are almost always hidden suspects at play. All right, let's look at a quick example. Here we've got data on 7 students. We see their GPA, and we see how many job offers each of them got. Now, just looking at this table for a second, a pattern kind of jumps right out at you, doesn't it? I mean, the story seems pretty clear, right? The students with the high GPAs, like Destiny and Rashad, they got a bunch of offers. And the ones with lower GPAs, like Jasmine and Taylor, they got fewer. It looks like an open and shut case. A higher GPA means more job offers. Simple. But an economist has to think like a detective. You have to ask the tough questions. Is GPA really the only thing that matters here? Or could there be some kind of hidden factor, a hidden suspect we're not seeing, that's actually influencing both their grades and their job offers? Well, this hidden suspect has an official name. It's called a confounding variable. Basically, it's some other factor that we forgot to account for, and it can create the illusion of a relationship that isn't really there. Honestly, this is the #1 trap that economists have to watch out for when they're working with this kind of data. So we've identified the problem, and we have our prime suspect, that potential confounding variable. So how do we deal with it? How do we account for it? It's time to open up the detective's toolkit, and we're going to start with a really powerful method called regression. Now, don't let the name linear regression scare you. It sounds complicated, but the idea is actually pretty simple. It's basically a statistical tool that takes a whole cloud of data points and finds the line of best fit right through the middle of them. Its whole purpose is to move past a simple guess and give us a precise, hard number that tells us just how strong the relationship is between two things. So, what happens when we run this regression on our student data? Well, it spits out that precise number we were looking for. It tells us that, on average, a 1 point increase in GPA is associated with, get this, 5 more job offers. Wow. All of a sudden, we've gone from just a vague hunch to a really concrete estimate. But hold on, a good detective is never satisfied with the first clue, right? We still haven't dealt with our confounding variable. What if the students with the higher GPAs are also the same students who are just sending out way more applications? Maybe the number of applications they sent is the real culprit here, not just their GPA. Okay, this is where we need to bring in a more advanced tool. It's called multiple regression. You can think of it as regression 2.0, a big upgrade. And it's brilliant. It's brilliant because it lets us measure the effective GPA while statistically controlling for other factors, like the number of applications sent. It lets us isolate the impact of just one variable all by itself. And check out what happens when we do that. Once we control for the number of applications sent out, the effective GPA actually gets a lot smaller. Now, a 1 point increase in GPA is associated with only 2.6 more job offers, not the 5 we saw before. See, by accounting for that confounding variable, we found a much more precise and probably a much more accurate answer. That's the power of multiple regression. So we've gotten a much better estimate for sure. But notice I'm still using the word associated. We're still just talking about a link, a correlation. The ultimate prize for an economist, the holy grail, isn't just finding an association. It's finding the smoking gun, proving true cause and effect. And that, well, that's the hardest challenge of all. To pull this off, economists have to get really clever. They go out and hunt for something called a natural experiment. This is when some random event happens out in the real world, just by pure chance, that basically creates a perfect, ready-made experiment for them. It creates a natural treatment group and control group, and it lets them finally isolate a true causal effect. Here's a great, kind of fun example to make this crystal clear. Let's say Jay-Z gives a speech at a high school, and just completely on a whim, he offers free college tuition to every single graduating senior. So that's our random events. Now, obviously, that offer is going to encourage a lot more students from that one specific school to go to college, right? So now, economists can come in and compare the future earnings of students from the Jay-Z school with students from a really similar high school just across town. And by doing that, they can finally isolate the true causal effect of a college education on income because they've stripped away all those other tricky factors like ambition or family background. And really, that's the key takeaway here. By thinking like detectives, by using powerful tools like multiple regression to control for those hidden variables, and by being clever enough to find these natural experiments out in the wild, economists can finally move beyond just seeing a simple correlation. They can actually uncover the true cause and effect relationships that shape our economy and, our lives. So now that you've had a peek inside the Economist toolkit, I'm curious, what about you? Is there a common economic truth that you've always been a little skeptical about? If you had access to all these tools and all the data in the world, what's one thing you would want to test?